So I hope you are doing well in your home. Stay in home, stay safe. So come to the topic here. So today I am going to deal with the topic speed control methods of induction motor. Speed control methods of induction motor. It is coming under the module 3 induction motor drives. It is coming under module induction motor drives. So in previous videos, so we have studied the single phasing and unbalanced supply conditions. So what is the performance of induction motor at the time of unbalanced supply? And we have studied the braking operation. There are three types of braking system: regenerative braking, plugging and dynamic braking, and based on that problems we have studied. And after that, transient analysis. So using what is the starting time, what is the braking time, those things we have to calculate in case of transient time. After that, there is a topic speed control method of induction motor. So we have made various methods to control the speed of induction motor, but as per your syllabus, we have only two methods. One is the stator voltage control method, another is variable frequency control method. Stator voltage control method, another is variable frequency control method. Here one question comes here. So what is the necessity of speed controlling? What is the necessity of speed controlling first? So as we know, induction motor is most versatile induction motor it is. In almost all applications nowadays, we are preferring the induction motor. Because of its flexibility, robustness and its characteristics made it to much useful. One thing is that it is the constant speed. It is having the constant speed. But it is having the induction motor is having the constant speed. But what happens here? In industry and domestic applications, we are using induction motor, but we cannot run the induction motor at one speed. We should have the variation in the speed. I can give you an example here. Fan. So fan is the induction motor. Are you running the induction motor or are you running the fan at one speed always? All the time, all 12 months? No. So depending on our conditions, depending on our environment, we are going to change the level 1, 2, 3, 4, 5 like that. So what it says, we require the variation in the speed. So it is a domestic application. In industry also, so many applications are there, they require the variation in the speed. So for that purpose, speed control is required. For the induction motor. Then how to do that? So we have two methods here. One is the stator voltage control method. Another is the variable frequency control method. Stator voltage control method, variable frequency control method. So today I am dealing with the stator voltage control method. So later on we shall study the variable frequency control method. Yes. So what is then how to do that? So what is the meaning of stator voltage control method? What is the stator voltage control method? Stator voltage control nothing but what? Stator is connected to supply, right? Stator is connected to supply. If you control the supply voltage, we can control the speed of induction motor. By controlling the supply, we can control the speed of induction motor. Again, there is a question here. What is the relation between speed and supply? How it possible? By controlling the supply, how it is possible to change the speed of induction motor? For example, fan. So just you are varying the level 1, 2, 3, 4. Your speed will change, right? Same thing, same operation happens here. So fan and its regulator together, we can say stator voltage control method. By controlling the supply, we can control the speed of induction motor. There is a relation between that. What is the relation? Supply voltage is relating to the torque. Then torque is related to speed. Like this, there is a relation. Supply is related to torque and torque is related to speed. What is that equation here? Here we have the equation. What is that equation? This equation you are much familiar. In case of braking system, in case of unbalanced supply, so we need repeatedly we are using this equation. T is equal to 3 by omega ms V square. These are the Rs plus Rr dash by S slip whole square plus Xs plus Xr dash whole square Rr dash by S. Yes, nothing but these are the slips. Yes, nothing but slips. These are the rotor resistance, stator resistance. It is the angular speed. From this equation, can you observe here is that there is a T here, there is a V. What is the relation then? T is proportional to V square. T is proportional to V square. So as you vary the voltage here, so T can be varied. We can vary the torque of the motor. Then what is the relation between torque and speed here? There is a relation. Torque is proportional to omega m square. For different applications we have different relation, but there is a relation between torque and speed. For a fan or for this kind of induction motor, there is a relation is torque is proportional to omega m square. So now by controlling the V, we are controlling the T, and by controlling the T, we are controlling the speed of induction motor. This one we have to remember. By controlling the supply here, we can control the speed of induction motor. Here. So like this we can control. Then how to control the voltage here? Practically. Theoretically, by relation we can say that. So there is a relation here, we can control that like that. But practically, is it possible? Yes, it is possible. With the help of what? With the help of one device, that name is called as AC voltage controller. I think you are familiar with this AC voltage controller in case of power electronics laboratory. In case using track and dia, we have controlled the lamp. We have controlled the speed of motor. So same operation takes place here. So nothing but AC voltage controller. It is also called as regulators. You can say it as regulator. In this case, what happens here? What is the main component here? Main component is track. Anti-parallel connected thyristors. So track is the main component, which is the semiconductor device. Using the track, we can control the speed of induction motor. Yes, for a three phase it is. So it is the induction motor, it is the supply, three-phase supply. So with the help of these tracks, three tracks, we can control the three-phase of induction motor. So it consists of what? It consists of gate. By controlling the firing angle of the gate, we can control the operation of these thyristors. By controlling this operation, we can control the speed of induction motor. This is for three phase. If it is single phase, so directly we can use the only one track. If it is single phase, can use the one track to control the induction motor. So in case of stator voltage control method, so to control the speed, we are controlling the torque. To control the torque, we have to control the voltage. It is possible with the help of AC voltage controllers, or you can say AC voltage regulators, you can say. Thank you.